This series of videos concerns embedded systems design and programming and how to do it with excellence whether you are new to the discipline or a veteran. There is a corresponding series of articles available at AQDI.COM. This video is about universal concepts that overarch design and programming practices, concepts that will save you time and money. Money? Yes, the world, even the world of embedded design, is governed by economics. Fortunately, we don't have economists writing code, but the discipline of economics is crucial to the success of any design. If you can't design and build it in a certain time frame for a certain cost or less, you don't eat. It's amazing the number of engineers who understand the laws of conservation of energy and momentum, but ignore economics. So let's talk about economics. We've all worked on projects from hell that seem to never end. The reasons for this are manifold, but there is always someone or a group of someones who don't understand that the programming and design tasks must be accomplished in finite time in order to ship a product and produce a profit. Product design is about accomplishing a result, not doing research. Now, this is a concept that new hire students struggle with. Sometimes the engineering managers or designers themselves don't comprehend the problem, or the MBAs in marketing keep moving the target. Whatever the cause, money don't lose at the money gain, from an Alan Parsons song, but you might get the axe in the process. Even if you get it right and beat the schedule and all the management charts, the sales team might blow it and you'll both be standing in the line for free soup. Economics is not a respecter of men. It is so rare to meet an engineer with an understanding and care for economics that you can distinguish yourself quickly with simple comments like this. What's the cost target? Knowing the cost target, you can work backwards and determine exactly how little budget you have for hardware and programming labor. This, however, is the right question to ask, but so many engineers ignore it altogether. Here's a list of economics-related questions to ask at the next kickoff meeting. What's the projected sales price? What's the needed cost to produce the product? What's the design schedule in calendar months? What's the design budget in man-hours and dollars? What is the support budget for the product after deployment? What is the installation budget? What is the intended monthly product volume? Who is the user? What is our department's historical labor rate? What is the reason to buy? All these things and many more bear on the economic aspects of your next project. Please understand that most of the answers are synthesized on the spot by the marketing staff. On our conference call, you'll frequently hear someone muffle the phone in their palm and shout one of these questions into the next cubicle. Not all the numbers are concrete, but at least you'll have a starting point, and you will be prompting the marketing and salespeople to do their due diligence before the next long-winded conference call. Let's talk about understanding the problem. Once you have the economic details on paper, you're ready to bang out some code, right? Wrong. The next step is creation of a specification that contains as much of the product's functional detail as possible. I covered this in depth in my article, The Unspoken Secrets of Software Development, available at AQDI.COM. The point I want to convey here is that your team must create and comprehend the functions of the product with their own brains first, capturing the details on paper in the process. All the powers of abstract reasoning must be used before the first line of code is written and the first two components are connected on a schematic. Many times I've come upon a perplexed programmer staring at a screen full of emulator windows with watch panes, call stacks, source and assembly dumps, etc. After about 30 seconds of inquiry and code inspection, I find that the programmer does not have a grasp of what he's coding for. But that does not stop him from coding. Man, I have to get this working. I'll just throw something together and let the emulator work it out. That creates a Microsoft-type situation where the code is obviously not designed correctly and is band-aided using a debugger and little abstract reasoning ability. Part of your specification process should involve interested parties batting around what it is and how it works, from high-level details to the nitty-gritty. This does not always happen, causing misunderstandings late in the project when engineers are heard to say things like, "You never told me you needed megabytes of memory." All your powers of abstraction should be brought to bear to understand the problem and its solution. If the marketing guys start losing consciousness in a meeting, just let them sleep it off in the corner while you engineers do the dirty work. While you're engaging in abstract thinking, consider other designs you've completed and how those sections of work may be reused. There is, of course, no seamless and cost-free reuse of hardware or software. I'll address those myths in a later installment. But copying a section of a schematic or program beats designing from scratch when something close to what you need already exists. Let's talk about testing your ideas. When you're sitting in those interminable product feature meetings, it's important to have everyone in the room walk through the function of the product in his or her mind. I know that that's an abstract process, and some people don't like to do it or cannot think abstractly, but it must be done. Writing out the operational steps a user would take helps. Often this activity happens, but only to a limited extent. Well, it appears we're on the right track, Bob. Go build me 10 and let's see what happens. Have you heard this? It's a recipe for budget and timeline disaster. Bob's going to make assumptions that the rest of the crew disagrees with, resulting in the waste of many hours of design and build time. This could all be avoided by walking through the details of product operation on paper first. Sometimes I'm called into a project late to fix some problem that's stalling production or causing field issues. This relates to everything from software bugs to circuit boards with no bypass capacitors to poorly designed communication protocols. All these issues could have been solved by testing the product before release to production. Let's talk about anchoring to reality. There is a danger in all this abstract thinking, that being cost overruns for implementing wild ideas. Man, if we only had a small nuclear fusion cell to power this product, the thing would run forever. Get it done, Janice. That's going to be a budget killer, no matter what the product is. As an engineer who has completed many designs, you have a feel for what is workable and what's not. Don't be afraid to pipe up and tell the MBAs that the features they're requesting will take months and much money to realize. You have to be able to put numbers to your assertions because the MBAs are used to whining engineer naysayers shooting down their dreams. Give them the numbers. You likely have a bunch of partially completed projects in the company past to base your numbers on. There are also practical details that the marketing people are not expected to know. They use highly complex products every day, having no idea what's in the box or what work happened to put it there. Treat them with kindness, but let them know what's possible and what's not. You must be an advocate of the practical, else you die. Are you seeing a pattern here? The best embedded designer is not the person who knows the most electronics or software theory. The best designer is the person who understands how the world works and all that theoretical stuff. That's why we don't see many companies run by PhDs, as they concentrate on one narrow slice of the universe and ignore economics and reality. Most products are designed by ordinary working slobs with BS degrees, but slobs who have been tempered by years of experience and wariness of hype. In our next video, we'll discuss product features.